wonderful, wonderful, wonderful moment. It's a time now to get good news about mathematics. Hi, everybody. This is Olenjolai single from the beautiful country that called Tanzania. I love so much my country. I would like to take this opportunity to welcome you into our training and learning system that we are going to introduce to you within few minutes. I would like to ask you that to pay attention and listen carefully. So before even I welcome, before I speak too much, I tell you about the truth of what we have prepared today. I would like to take this opportunity to welcome every viewer, a national and international viewer, to just to join me in these programs or in our online school at called TANZANIA Online Advanced Secondary School in square bracket OLENJOLAIM. Again, this is a national and international program. I'm a national teacher in basic applied mathematics from 5 and from 6 years. So I used to take these contents and I have some official channels or official platforms that I'm using. One of them is called this is one of my official YouTube channel. I would like to welcome you into Tanzania Online A-Level Secondary School in square bracket OLENJOLAIM. According to the word of God that written in the book of Proverbs 29 verse 18, it says that where there is no vision, people perish. If we don't have any vision, if Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM does not have any vision, then this is going to perish. That's the truth, and the word of God is truth. So the next question you are asking yourself after I took a few minutes to welcome you, you say, thank you, Olenjolai, for welcoming me. But I want just to know what the visions of Tanzania Online Advanced Secondary School. That's the good question. The vision we have, which has been declared at the picture in our mind, this is what the Lord has shown us in picture. It's not actual that real. For my private life, it's real, but for the life of my students, it's not actual real. It's not practical yet. I don't have the evidences or testimonies. However, for the analog system, I have so many testimonies from my previous students, which I call them Olenjolai's alumni. But in case of the digital, this is just the commencements of this program, so I don't have too much of the testimonies. I'm waiting the number of the testimony from my online advanced secondary students. So this is the vision that has been written in our mind, right? In our mind. I see this thing, right? I see this situation happening in the mind, in the life of our students. Means that I see, or we have an assignment to teach and train some group of students who will be ready to extract knowledge, understanding, and wisdom from the classroom instructions in mathematics and science, subjects, and combine it with the knowledge, understanding, and the wisdom that we teach them to extract it from the Word of God written in the Holy Bible, and combine these two knowledge together and solve the real life problems. You are an advanced secondary student, so we have to expect it to solve even intermediate real life problems. So the main objective of Tanzania Online Advanced Secondary School is not to prepare you for the continuing assessment. It's not prepare you for the certificate secondary education examination. But the main objective is to prepare you to solve real life problems, because that is the objective of education. We used to go to schools not to seek for the certificate. We used to go to schools not to just to study in order to become popular in the family or in the regions. We used to go to school to seek for the knowledge, understanding, wisdom in order to solve real life problems. Possibly, I know that what I'm telling it has been lost for the time more than 20 years ago in our beautiful country. But I want just to tell you that it's a time now for us to redeem or to get redemptions into our previous focus of our educational system. Educational systems have so many challenges of Tanzania, but sometimes you can complain a lot about designers of educational system, while even yourself you didn't create your own educational system. So this is the supplement programs to your formal classes. So that's the main objective. So we'll be thinking how to take it. However, that will be helping you in your continual preparing, to get good preparations in continuing assessment and in certificate secondary education examination. But that's not our main objective. It's a specific objective. One of our specific objectives to prepare you to master and pass your continuing assessment. It means that to pass all the tests of basic applied mathematics and also to pass even other subjects in which we are going to teach you. But our next specific objective is to prepare you for the NECTA exam. right? If you're Tanzanians. If you're international students, just to prepare for your continuing assessment, it means midterm test, terminal, annual exams, any kinds of them. But if you and then at the end, you have to sit for the OT, for the national exams, even in your country, in the African continent. Okay, so that's the piece of information that we would like to share with you in advance. So again, another thing that before I take you into what I've prepared you today, I would like to take this opportunity. I welcome every viewer. Whether you're a national, international student, you are warmly welcome. Whether you're a parent, you're a guardian, you are a sponsor, or you are just a father of certain students in advanced education, you're a teacher, you are an engineer, you're a scientist, you are a leader, you're a politician, you are watching this program right now that is going to transform the life of the Tanzanians and millions and the life of present and future generations, you are warmly welcome. Stay tuned and keep and enjoy the beauty of basic applied mathematics and advanced mathematics in our online institution. So the next thing which I want just to share with you before I take you inside is registration. Whenever you go to any physical school, on the first day or the first week, you'll be doing registration, right? So what are the steps for you to be registered into ASO? TASO is Abbreviation of Tanzania Online Advanced Secondary School in square bracket Olenjolai. So follow the following steps, right? Follow the following few steps. Within a minute, you are done. The wonderful thing that it means that this is lifetime, one lifetime's registration. So you don't need to register yourself maybe 3 times or every time. No, you have to register yourself only once and then it's done. And I know that many people, they like such kind because, you know, registrations are sometimes different challenges. So we ask you to create or open a new email. Create or open a new email. Example of the email, you can have Yahoo email or you can have Gmail. All right? So that is the first step. If you have an email, skip the first step, go to the second step. The second step, we ask you that to sign in. Say your name, sign in Sign in YouTube. Sign in YouTube platform. Then when you are in YouTube, it means to sign in, get in YouTube, that's the meaning. When you're in YouTube now you have an option to search to ASO. And don't write to ASO. There, the name of our channel in YouTube, our YouTube channel is called Tanzania Online A-Level Seki School in square bracket OLENJOLAIM. Copy and paste. Copy this sentence and then paste it there. This is the abbreviations because of the space, I cannot write it entirely, right? And then the fourth step, we ask you, we have departments, click it. So we have departments, we say that click the software button, so it's called the play list. Okay, again, in this online advanced secondary school, we have also some departments. We have more than 4 departments. More than 4 departments. We have departments of advanced mathematics, we have departments of advanced physics, we have departments of advanced chemistry, right? And then we have departments of Kingdom of Heaven. Okay. So in all of these departments, we have different subjects. For example, departments of advanced mathematics. Yeah, so the departments here, I think that I have to do minor correction. Okay, I have to do minor correction for you. The minor correction I have to do there is actual, that is not departments of basic applied mathematics, departments of advanced mathematics. So do that minor correction, please. Do it with me. Okay. So it's Department of Advanced Mathematics. Okay. So remember that this is still the word Tanzania. It's a beautiful country where God lives. Okay. Then this departments of what? Advanced mathematics. Departments of advanced mathematics. So in departments of advanced mathematics, we are teaching 4 subjects. Advanced mathematics for the Form 5, advanced mathematics for the Form 6, basic applied mathematics Form 5, and basic applied mathematics Form 6. So we are teaching 4 subjects, and we ask you to be an active student. How are you going to be an active student? You have to means that we're expecting you to participate in every aspect of learning process of this. Okay, so if I give you the homework, then you have to do. You listen careful. You're writing everything that we are teaching you, and you follow along. So it means that, for instance, here we are, as I say, we have 4 departments at this moment. We are going to add more departments, more than 4 departments. So each department, we create a playlist in YouTube, right? For example, we have a department of advanced mathematics, where we find all the videos of 4 subjects. Again, we have a subject called basic applied mathematics. So we use basic applied mathematics. We have a collection, basic applied mathematics form 5. We have a playlist called basic applied mathematics form 6. So in that playlist, you will find the collections of consecutive or sequential or systematic videos or systematic sessions. So you will find that the videos are being arranged session 1, 2, 3, 4, 5 up to the last session. So make sure that you click the playlist, because playlist you will find once you see, because when you search the Tanzania online A-level circuit school square bracket, you will find that these buttons, and it has a national flag. So click it there, and then there is a text on this side. So if you click, you'll find that you'll find the word written home, then videos, then playlist, then you have community, then you have community, then we have channel, then you have about. So just click this playlist, and then you'll see the list of playlists. We have so many playlists in order to help our students to get the collections of our contents. The second stage, for you now to register yourself. All of those are just the preparation for you to register. But the registration basically is on the fifth stage. That look at the bottom of your video, on your right hand side, on this right hand side, the button which has been written subscribe. Okay? Which has been written subscribe. So these buttons, then just click this button once. Just click it, just take the cursor and click it, and then the text will change into subscribing, and the bell, the icon of the bell will appear. So you click it. When you click, choose the options of all. Because you see 3 options, choose the options of all, then you've done it. You have permanently subscribed into our channel, and hence you have to start enjoying the beauty of the contents that we are training and teaching you. So click that button, and then the next stage, which is number 60, means that you can click some icons that you see at the bottoms of this video. One of the icons, you can click the buttons of like, or you can dislike, right? Or you can also click the icon of share, to share, because I know that you are going to enjoy our contents, all these contents. And because you're going to enjoy, whenever you have something which makes you to be happy as a human beings, always you can speak it publicly. You can you want other people to know that you are happy, or you have been satisfied from what you are watching, or from what that you heard, from the word that you have heard, or from what that you are reading, okay, or you are sensing, etc. So I know, because you enjoy our contents, so you want to share these contents with others. It is legal for you to share with other advanced secondary students in the entire country of Tanzania. So if you have your friends who are studying advanced educations in Rukwa, you can share these contents. You have your friends who are studying advanced mathematics in Kigonsela, maybe in Ruvuma, you can share this information, these contents. He can access, because right now there's no any physical limitations of this program. It can benefit Tanzanian students in any region, and even in the world, in the district place, in the villages places. So every village, every wadi school right now is going to receive the great power of the training in science. So I believe that after some few years, I believe that then the ratio of the students who will pursue science will be increased, because the challenge is the training system, the learning system, and also scarcity of the teachers. That's the great challenge that we are trying to meet. But even not only also scarcity, it means that the financial status, it means that we have, in most of the families experience lack of financial, okay, lack of financial. That's why that God, who has given me a gift of teaching, has sent me to conduct or to do these programs and distribute these contents to all his advanced secondary students, because you are students of God. and offer it free of charge. So just to omit you from bondage that if I could have money, I could have attended this fantastic session. But God is a sponsor of this program and is going to pay me more than you think. Wonderful. Okay, so it means that click like on this slide. So you can click the icons share there at the bottom. Share to what? Okay, share. You can share with your what? With your friends. Okay, friends or other students. You can share this link through what? Through Facebook, through WhatsApp, through Telegram, through Instagram, through Twitter, through email, okay, through debits and other social media. Wonderful. I think that I've given you, excuse me, I've given you enough information for you to go through. So let us go inside session 1. So welcome into session 1 to session 3. I'm going to teach about graphs and graphs, domain, and range of exponential function. These contents are dedicated to pre-Form 60 and Form 60 students of class 12 in some of the countries of the following combination: PCB, CBN, CDA, ECA, HGE, CBG. PCB, P standing for Advanced Physics, C standing for this C and this C and this C and this C. So this 4C, except this one, stand for Advanced Chemistry. This B and this B and this B and this B stand for Advanced Biology. Then this G stands for Advanced Geography. Then this N stands for Advanced Nutrition. Okay? And then this A stands for Advanced Agriculture. This E stands for Advanced Economics. This C stands for Advanced Commerce. This A stands for Advanced Accountants. H stands for Advanced History. G stands for, okay, G, the same that you can. G stands for Advanced Geography. And E stands for what? Advanced Economic. Wonderful enough. I know that you're ready to take advantage of these contents. So let us start with a quick review of session 2. In session 2, basically it has been titled about laws of what? Laws of exponential. Laws of exponential. It has been titled in session 2, okay? Exponential functions. So I taught you some of the laws, if you do remember. One of the law is the law of product. You say if you have a power x, then we multiply with a power x. It means that two exponential functions of the same base a, then or a power y, but different exponents of the same exponent. This will make a power xe plus 1. Again, in case that you have, let's say, a power xe over a power y, this is law of division, then this one we define as a xe, a power xe minus what? Minus 1. So just I'm reminding you some common laws. But again, I told you that a power 0 is 1, and again, there's another law that we say, if you have a power negative 1, this is equal to 1 over a. Or a power negative x, for instance, is equal to 1 over a power x, right? Then the other laws, we said that if you have a power x, then power y, this would be a xe y. So, etc., etc., etc. So we discussed the number of laws. And hence we try to solve some questions, or we've been solving different questions with you. So, and I left the homework for you. I left a number of the questions which I've given you the foundation. And I believe that you have done it. However, that you didn't submit in the comment sections or in other methodologies that I will share with you as we continue this program. So welcome to enjoy the beauty of basic applied mathematics. Tell your neighbor, do you love basic mathematics? Ask your neighbor, please. Do you love basic mathematics? What is he or she saying? Huh? Okay. So let me just do one question. It means that let me just do correction for the one question to encourage you, because I know there are some students who are who used to consider themselves they are very weak in mathematics. So correction of of homework 2. Let me focus into question number 5. Question number 5, which I left it to you. Let's say question number 5 for B. Okay, so the question stated, determine the value of x in the following equations. So simply the question said that determine the value of x. Are you ready to hear the good news? of algebraic mathematics in the following equation. Okay? In the following equations. So we have A. This is what? This is B. Let me say because I said B, it is 3 power 2x, then minus 3x minus 6. Answer is equal to 0. So I have to find the value of 40 of x. Okay, so for this question, it's a simple question. Solution. Okay? So the first step, we said that simplify the given equation. Simplify what? 3 power 2x minus 3 minus 6 is equal to 3 power x minus 6 is equal to 0. How do you simplify? Ladies and gentlemen, we have 3 power 2x minus 3 power x minus 6 is equal to 0. So ladies and gentlemen, this is 3 power 2x minus 3 power x. This is equal to what? Is equal to 6. Right? Is equal to 6. So you have to remember the same things. So you go for the second step. Okay? The second step, we say that recall. We say that if you have A power what? So we have, because these bases have been subtracted, can we solve this problem easily? So that will be 3 over 2. Okay, I will counter check this question if there is a mistake. So I will counter check this question, please. Okay, so let us go. I've already counter checked the question, so it's fine. So there's no need for us to simplify. Okay, there's no need. Okay, just fine. Yeah. So when we have this kind of a problem, we can keep on simplifying, and then we say that these two, 3 power x, we can write that this is according to the laws of logarithm. Yes, the second step, we call law of exponent. Which law of exponent? So listen carefully. The law of exponent, the one which is saying that a power xy, this is equal to a power x, then in open power. So where do we apply this? We apply in this term. So there we have 3 power 2x, means suppose that y it is 2 and x it is x. So this one, in mathematics, according to the laws of the exponent, you can express this 3 power x, then power 2. Right? So for that case, if that's the case, here we have 3 power 2x minus 3 power x is equal to 6. So this one I can write as 3 power x square minus 3 power x minus 6 is equal to 0. Right? So this one suppose to equation 1, and right now we have equation 2. So please pause the video and copy this instruction for you to register and even to share with other students. I know if you don't follow these instructions, you can struggle a lot in order to achieve your goals into ASO. So make sure that you follow this instruction for you to save time. Because in advanced education, always time is rushing, right? So ladies and gentlemen, we have 3 power x squared, then we have 3 power x minus 6 is equal to 0. So suppose that this is equation 2. Okay? So we go for the third step. Third step, ladies and gentlemen, lovers of basic mathematics, you have to say that let 3 power x is equal to m. Right? Is equal to m. So if that's the case, if you substitute there, we have m squared, and then there we have m minus 6 is equal to 0. So, ladies and gentlemen, m minus m, that's it. This is the trick to solve all the questions of exponential function which are in that form. So this is equationality percentage. So we go for the first step. Okay, the first step, we say that solve for what? Solve for m. Solve for m by using your scientific calculator. Okay, so you have your scientific calculator. If you don't have, you can order in our TOASO, TOALO, means Tanzania Online Advanced Library. So to solve it, we have to press mod up to equation, then that is 2 degrees, and then coefficient of 8 is 1, and then coefficient of b is -1, and coefficient of c is -6. So the value of m, the first value of m is 3, and then the second value of m is only 1, second value of m, which is equivalent, so this is a 1, is equivalent to what? To -2. So m is what? 3, and the other is -2. And you can prove, because if you have m minus 3 times m plus 3, then you get that equation if you expand it. Okay? So if that's the case, then we say, okay, fine. So remember that you have to understand that we let m is equal to 3x, right? So m is intermediate variable, intermediate independent variable. So you have to understand. So for that case, now we go for the fifth step. The fifth step say that find x from what? From the equation m is equal to 3 power x. So for the first value m1, 3 is equal to 3 power x, and this is 3 power 1. Remember that I told you the law that if two exponential functions which have the equal sign between of the same base, then we cancel bases. So this base and this base cancel, then x is equal to what? To 1. But the equation won't be valid if you have m is equal to -2, because we cannot get the value of x in this case, because we should not apply the concepts of logarithm and even as well logarithm of negative number. So simply, this one is not a valid value. It's one of the roots of the equation of this quadratic equation, but it's not valid. So therefore, because we've been asked to find the value of x, so we say the value of x is 1. And you can prove it before you conclude. Take x is equal to 1. So 2 power 1, no, 2 times 1, it is 2. 3 power 2, it is what? It is 9. Right? Minus what? X is equal to 1. 3 power 1 is 3. So minus 3. Then minus what? 6. So 9 minus 3 it is 6. 6 minus 6 it is 0. Is it true? Yeah, it's true. The goodness of these questions, most of the questions in basic applied mathematics are, you can prove them before you collect the exam. Wonderful. Okay, so that is the correction. So let us go into today's message, into today's revelation. And the subtitle there is being titled as Graphs of what? Of exponential function. We are still teaching exponential function. We didn't teach you about logarithmic function. So let us start from there first, and then we'll go into the second concepts of domain and range. Graphs of exponential function. Stay with me. Graphs of exponential function. Say it again. Graphs of exponential function. Graphs of exponential function. Remember, how many types of exponential function do you have? 2. We have common exponential function and the natural exponential function, right? So what do you say? We say that in drawing the graphs of exponential function, this one, okay, the function f of x increases as x increases or grows exponentially. So we say that in drawing the graphs of exponential function, exponential function, such as a power x, and a should be greater than 0, as we said. So we say that in our drawings, say that the function or the value means that the value or the dependent value, this is dependent value, right? In most cases, the dependent variable, which you call it what? Y in most cases, and this y is equal to f of x, right? Increases exponentially. So increases exponentially, not linearly, like what we taught you in O level, exponential. So this is the first point I want to make. And this part is very important, and it has a real life applications in economics. There's a real life just applications in populations. When I say populations, even in biology, because we can have populations of bacteria, right? Populations of the particular organism. Also populations and people, inhabitants of Tanzania, okay? So it means that this will indicate, these graphs are the graphs which can give us deduction whether there is a growth or a decay. Growth of the population, when I say populations, maybe populations of productions in a particular industry, or there's a decay of that. So it means that the graph or the value of y or dependent variable will be increasing exponentially, right? Or we call it f of x, will be increasing exponentially. That's the first equation you have to remember, or grows exponentially. So we'll be increasing exponentially if A will be increasing exponentially if the base of the function is greater than 1. Again, we say that, then we say f of x, which is equal to y, decreases, okay, decreases exponentially, when the value of a range from between 0 and 1. When the value of a is between 0 and 1. So the value of the base is less than 1, but the base is greater than 0. Okay? So there's a decrease, decreases, so it decreases exponentially. So the value of y, or the dependent variable, decreases exponentially when the value of the base range between 0 and 1. Okay? Which is equal to decay exponential as x increases, as x increases. So we said that the graph of exponential function, which it's a dependent variable. It's dependent variable, which we call y is equal to f of x, increases exponentially. It's called the grows exponentially. Grows exponentially. And then the graph which decreases when the value of x increases, we call it in basic auxiliary mathematics, or in mathematics, decay exponential. So we say exponential decay, say that is the graph whose value of f of x is equal to y decreases exponentially. Increases exponentially as x increases at the point. Okay. So we have exponential decay and exponential growth. So let me draw for you exponential. This is generally, but I'll give you examples soon. Exponential growth. Exponential growth. And remember that exponential growth, this happens when the base of the function, of an exponential function, is greater than 1. So simply say that sketch graph of exponential function f of x a power x if what? A is greater than 1. The base is greater than 1. Okay. So this is our x-axis. This is the y-axis. And this is x-axis. Okay. Then suppose that, should we label? Yes, okay, suppose that we label our graph this way. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Then here we are. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. So this is 1, 2, 3, negative 1, negative 2, negative 3, negative 4. This is negative 1, negative 2, negative 3. This is 1, this is 2. Okay? So the exponential growth will be the graph that will be in this form. So it's growing what in exponential. So this is y-intercept. So this is a graph of the function f of x is equal to a power x. But if a is greater than what? If a is greater than 1. You know that if a is equal to 1, then we don't have exponential function because 1 for x is 1. Okay? So ladies and gentlemen, this is figure 3.1. So graph of what? So we can label as graph of what? Graph of exponential function. Graph of exponential or graph of exponential function. Wonderful. Okay. Welcome our dear viewer. to enjoy the beauty of basic applied mathematics. And today we are teaching about the graphs of exponential function and logarithmic function. Yes, the graphs of exponential function, domain, and range of exponential function. So this is the exponential growth. So you see that the graph is growing. So here it is decaying, kind of decays. It means that because this x-axis will be something called asymptotes. This graph will never touch the x-axis. So there is no x-intercept, right? That's one of the points that you have to note. There's no x-intercept. So for example, this point, suppose at this point A, it is 0, the value of x is 0, value of y is what? It's 1. So I say that from figure 3.1 above, say that the graph or the function f of x is equal to a power x has only what? Has only y-intercept. Has only y-intercept. And this y-intercept for that case, which for this case is what? It is always 1. The y-intercept is always what? 1. So we say that f of x is equal to a power x does not have what? Does not have the x-intercept. Why does not have x-intercept? That's a very important question. So the question is why? Why? Why does not have the x-intercept? So we say that because the graph, because the x-axis of the function f of x is equal to a power x acts as what? Acts as asymptote. Say asymptotes. So act as asymptotes. Let me check the spellings of asymptotes. Approaches this one. Horizontal asymptote. Act as watching. Okay, simply just call it AC. Act as horizontal. Act as horizontal asymptotes. Act as horizontal asymptotes, where the graph of f of x is equal to a power x touches it at infinity. So this is a general graph. What I'm teaching you right now, I'm not talking about the specific graph. This is the general graph, because when the value is of the base of the exponential function is greater than 1, we have so many possibilities, billions or trillions of possibilities of the base. Okay, so that's what we are discussing in general. So we have two observations. The first observation that we observed it from the graph of 3.1, it means that regardless of the value of the base, the y-intercept is always equal to 1. But the second observation, if you observe the figure 3.1, the function does not have what? The function does not have, so the function does not have the x-intercept. Why? Because the x-axis because the x-axis of what? Of f of x is equal to a by x acting as horizontal asymptote, where the graph of the function f of x is equal to a by x touches it at infinity. At infinity. So this graph will touch this x-axis at what? At infinity, not maybe at -4 or -5 or -20. So those are the two observations that I want to declare to you, I want to introduce when I'm building the foundations of graphs of exponential and logarithmic function. Do you have any question? Do you understand what am I teaching you? Please, if you have any question, don't hesitate to ask in the comment section. So that is about exponential growth. Okay? Then let us sketch the graph of the general exponential function, which has characteristics of what? Of decay. Okay, of decay. So this is Roman B. We say that exponential decay. We use this concept in applications of differential equation in calculus. Okay, exponential decay. We use it in research. We use it in presentations of the data or in drawing conclusion. So that's called exponential decay. So let us have a problem. Sketch the graph or plot the graph of what? The graph of the exponential function f of x is equal to a power x in such a way that a ranges from what? Between 0 and what? So between 0 and 1. So a ranges between 0 and 1. So it means that a is greater than 0, but a is less than 1. What will be the nature of the graph of this exponential, this type of the exponential function? Because the base is the only one which can change or which can give us millions exponential function. So ladies and gentlemen, let me sketch or plot the graph so you can see it. And why am I teaching you the general concepts of graphs of exponential growth and exponential decay? Because these are the common types of the graph. So whenever you see any questions which ask you to plot the graph of exponential function, the only technique you have to check what you have to check the base. Once you check the base, you know the nature of the graph. If the base is greater than 1, then that's it, exponential growth, and this graph always will be in this form, right? In this style. If the value of the base is less than 1 but greater than 0, then we know that that is exponential decay. Wonderful. So you have two types of the graph in what? In the two types of the graph in exponential function. So wonderful, wonderful, wonderful. So this is the x-axis. So 1, 2, then you can have, let's say, this. You have 1, 2, then you have 1, 2, then on this side you have 1, 2, then you have 1, 2, then you have 1, 2. So then we have x-axis. So this is the x-axis. So this is y-axis. So 1, 2, 3. Then 1, 2, 3. 1, 2, 3. 1, 2, 3. Then what? 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so these are the coordinates. Okay, so this is 1, 2, 3, 4. This is 1, 2, 3. This is -1, it's -2, it's -3, it's -4, it's -1, it's -2, -3. Okay, and here it is 0. And here it is y-intercept. Because even if that maybe it is a half power 0, it is 1. Okay, so listen carefully to the nature of the graph and see the wonders of mathematics. This is x-axis. So the y doesn't will be the same, but now the graph, the nature of the graph will be different. Okay? So many graphs of exponential function which obey that condition are exponentially decaying. Okay? So this is point, let's say b, it's 0,1. So this one is a graph of f of x is equal to a power x. The condition is 0 less than a and a less than 1. So you can sketch it correctly. So it's decaying, it is decaying, it is decaying, it is decaying. Okay, so this is what? Figure 3.2. So this is the exponential thing, exponential decay. Exponential decay. This is the graph. All the graphs which will obey this condition, which best obey this condition, will be in this nature. Okay? Wonderful. So let us see the example. Okay, let us see the example of this concept that I'm teaching you. I've been using letters as just to explain the concept in general. Let us be specific. So let us sketch the graph of one function. Okay, so this is example. Tell me the number of example, please. I forgot. So tell me the number of example. Okay, ladies and gentlemen, this is example 6. Example 6 from the book Basic Applied Mathematics for A-level students, Form 5 and Form 6. And the question states that draw what? Draw the graph, draw on the same axis, on the same axis, the graph of a f of x is equal to 3 power x, and b g of x is equal to 1 over 3 power x. Another question. Please copy that question. Draw on the same axis. Draw on the same axis the graph of a f of x is equal to 3 power x, and graph of b g of x is equal to 1 over 3 power x. Wonderful. Solution. Okay. If you check this question, you can realize that these are the two exponential functions that we've been talking about, right? So from Roman A means the function in A, this f of x is equal to 3 power x. So for this case, if you remember, the exponential function where f of x is equal to a power x, where a is greater than 1, then we say that this function gives us, so we find that it is true, a if you compare x is greater than 1, means 3 is greater than 1. If that the case, we expected the graph, the nature of the graph, to be what? Exponential growth. Exponential growth. This is the first step. You have to analyze the problem. Okay? Then B will be given f of x is equal to what? 1 over 3 power x. You have to recall, we say that if the exponential function is f of x is equal to a power x, such that 0 less than x less than 1. Then we say that for this case, if you compare a is equal to 1 thing, so you find that it is true 130 is greater than 0, that's less than 1. For that case, it's a graph we expect it to be what? Exponential decay. So that's the expectation. So we have two graphs on the same x and y axis. So we go for the second stage. So the first step, remember that you have to check. You should know, because we have given you the information, the general overview. But this is specific graph now. Before I was teaching the general graph, that's what I was using what letters, A and X. But here the value of A is no. The second stage, we say that draw it. So in order to draw, to know, we know the y-intercept will be the same, but how about the width or the path of the line? Because this is a specific line. So we say that draw it. Draw the table of values. So you have to take some few values of x. So here is the table of values. We have this, and we have this. Okay? So you have x, we have different values. So you have to choose. You have to choose maybe from -2 to +2, or from -3 to +3. So this one will be 3 power x, means f of x is equal to 3 power x. And this one will be the row of 1 power 3 power x. So let us start from x is equal to -3, -2, -1, 0, 1, 2, 3, 4. So the value of x, it is what? It's -3. So you can take your scientific calculator to simplify your life. So clear, firstly, the scientific calculator, turn it on and then clear. So then we have, you can say it means that just you have to find 3 power -3. The answer is 1/27, or in decimals. So we say that is what 3 power -3. The answer is 0.037. You have the same value of x, which is what? -3. So you have 1/3 power what? Power -3. So the response is what? Is 27. We have -2. We have 3 power -2. So 1/9. The response is 0.11. Then we have what? 1/3, 1/3 power what? Power -2. The response is what? This is 9. Then you have what? To find 3 power -1. This is 0.3, not repeating this one. You have 1/3 power -1. The response is 0. Then have x is equal to 0. 3 power 3 is what? It's 1. Then if x is equal to 0, 1/3 power 0 is 1. Then you have x is equal to what? To 1. So if you substitute 3 power, so it is what? It is 3. 3 power 1 is 1. It's what? It's 3. Then 1/3 power 1. This will make what? 1/3, which is 0.33. Then have when x is equal to 2, the response will be 9. And then 1/3 will be 1/9. And this 1/9, we have a corresponding value of 0.111. When x is equal to 3, so 3 power 3 is 27. But this one is 0.077. When x is equal to 4, you have 3 power 4, which actually fill the blanks. let us leave it for you. So this is what? This is table 3.1. So these are the steps you have to follow on solving any question that asking you to sketch the graph of exponential function. So the third step, let us sketch now. Sketch the graph. So to sketch the graph, we have the values of y are growing exponentially, and others are increasing while becoming exponential. So let us see how we can navigate or how we can plot this graph. So you know, because the graph will be lying along the positive x-axis, so it can decrease the negative y-axis. So 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 1, 2, 3, 1, 2, 3, then 1, 2, 3. One, two, three. 1, 2, 3. 1, 2, 3. So this is x-axis. So this is the x-axis. So you can have this is 3, this is 6, this is 9, this is 12, this is 15, this is 18, this is 21, this is 24. So 1 is somewhere here. Then this is negative 3. This is 1, 2, 3. Negative 1, negative 2, negative 3. Okay. So let us plot. When x is equal to negative 3, y is equal to 0.037. When x is equal to negative 3, y is the smallest value here. When x is equal to negative 2, y is equal to 0.11. So y increases smaller and smaller value. When x is equal to negative 1, y is equal to 0.333. Okay? When x is equal to 0, y is equal to 1. X is equal to 0, y is equal to 1. Y is equal to 1. When x is equal to 1, y is equal to 3. When x is equal to 1, y is equal to, so this is just like this is the point. When x is equal to 2, y is equal to 9. So when x is equal to 2, all of y is equal to 9. When x is equal to 3, y is equal to 27. So 27 is somewhere else there. So to sketch our graph now, then we have to join all of these points. So it's still continuing graph. So this is the sketch. So this is the graph of what? It's the graph of f of x is equal to 3 over x. Okay, so it's what, as I said, this will be exponential growth, which is true. And let us take the next one. When x is equal to what? Negative 3, y is equal to 27. When x is equal to negative 3, this one, y is equal to what? 27. So it's somewhere there, far. So when x is equal to negative 2, y is equal to 9. When x is equal to 1, y is equal to 3. When x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 0.3. When x is equal to 2, y is equal to 0.1. When x is equal to 3, y is equal to 0.3. So if you join these points, so the graph is continually okay. So this is what? These are the points. These are the points. So this is the graph of the function g of x. G of x is equal to 1 over 3 x. So those are the two graphs that we will ask to sketch. Figure 3 times 2. So those are the two graphs that we will ask to sketch. Okay. So after sketching that, I would like just to introduce to you the concepts of domain and range of the exponential function, which you have already built the foundations when you've been learning the topic called the function. Okay, topic that's called the function. So we told you we built the foundation, but we'd like quickly remind you. Okay, we'd like quickly to remind you in order for you to enjoy it. Because once you know it, it's very simple for you to enjoy it. Okay? So we say, what is domain? An exponential function is a property that the input values are the domain. And output values are the range. Domain refers to the set of full or real numbers, while range is a set of positive real numbers. Depends on that. So, ladies and gentlemen, let me build a strong foundation in your mind about domain and range, which will be talking a little later on. So you have the meaning of domain and range. This is the last concept. After this concept, after teaching you until you understand this concept, I end session 1. So domain and range of what? Of exponential main range of exponential functions. Main range of exponential functions. So the fundamental question is this. What is the meaning? What the meaning of what? Of domain. What is the meaning of what? Of domain. Okay? So you say domain. Domain is a set of values of x. This is the set of values of what? Of x. Or in other words, you say that in the domain of exponential function is the input values, or it is the input values of the function, of the exponential function, let's say. What do you mean? So domain means input values. Remember that in your mind. This means what? Input values. Input values. Okay? That means of what? Of domain. And these are the values, set of values of x. Then have another question. This is question 1, this is question 2 in this subpart. Define range of the exponential function. Exponential function, right? What the meaning of range? So range is a set of values of y. Or simply say that the range you say that range is a set of values. This is the set of values of output variable. For this case, in most cases, output variable will be what you want. I mean 40 of range. So that's the point that we want to make. So for example, we say that from, because when we ask to find a sort domain, draw on the same graph. For example, from the graph or from the plot, from figure, from figure 9.1, no 3.1, we say that domain are the values of x. If you look this graph, it also is going to involve or satisfy all the values of x. Similarly, even in exponential growth. Okay? So you find that because of the nature of this graph, all values of x will be satisfied. Okay? Let me repeat. We said domain are the values of x which satisfy what? The given what? The given function, exponential function. So a set of values of x in the function. Okay, so for example, if you refer figure 3.22 above, figure 3.2, this is 3.3 because you've already sketched the two graphs, so this is 3.3. For example, if you want to use the graph above or the graph on the other sides to find the domain and range of this function of f of x is equal to 3 power x and g of x is equal to 1 over 3 power x. How are we going to find domain? So as I said, domain is the value of all real numbers. Or say that domain are the values of x. So the graph of exponential growth, if it's moved this way, it does not touch all the values of x. But the good thing that when it is going this way, it touches all the values of x up to negative infinity. So it means that the graph will be satisfied. Again, the exponential decay will be moving this way all to the positive infinity values of x. So simply say the domain is all real numbers. So you can write just domain of what? Domain of f of x and what? G of x is what? Is all real numbers. All real numbers. All real numbers are the domain of what? Of the given function. Okay? So this is just an extra concept. For example, if you want to use that graph to find what the domain and range of the given function. Okay? So that is domain. How about range? The range, we say, is the value of x. Graphically, the range is the value of x where the graph satisfies. So simply, we say that the range, these are the values of what? Values of y. In figure 3.3, we say that range for that case, you have to check the graph. So the graph, we say that the graph itself, the minimum value of y, means that we say that the minimum value of y is a number near to what? Near to 0. Number near to what? To 0. Okay? So simply say that range of what? Of the function f of x and g of x, this one will be what? Will be y should be greater than what? 0. Meaning that we don't have, the graph does not cross the x-axis onto the negative y-axis. That's why it is like that. Okay? So we say that it's simply, now mathematically, we can write this way. So domain is a set of real numbers. So domain, we say that is x such that x is the element of all real numbers. That's domain. Then again, we need what? Range. Range for this case, we say that what? Range is the value of y such that y should be greater than 0. This is how you can write the response, your responses of domain and range in terms of what? In that form. Okay, so ladies and gentlemen, this is all about domain and range and graphing the exponential function. And I would like just to leave the homework for you. This is be example. Example 5, example 6, example 7. Okay? So you say that A, plot the graph of exponential function f of x is equal to 2 plot the graph for the function f of x is equal to 2 power x, and another function which is g of x is equal to 1 over 4x. Then Roman 1. Okay, Roman 2. This is B, excuse me. Roman B. B, state domain and range of the two functions of f of x is equal to 2 power x and g of x is equal to 1 power 4. 1 is equal to quarter power x. So make sure to do that question effectively, and you have to enjoy the beauty of basic mathematics. Before I end this session, I would like to give you two announcements, and then will be the end of this session. And I would like to invite you first of all in the next session, which will be session 4, where I will be solving problems about the graphings, the exponential function, domains of exponential function, and logarithmic of exponential function. We have our online library that's called the Tanzania Online Advanced Library, where we are equipping our students with our reference materials. This is called Basic Applied Mathematics Syllabus for Advanced Secondary Education Form 5, Form 6. You can order a copy of it or you can order it yourself. So just go the descriptions below there, then you see the process. Then again, you have the book called Basic Applied Mathematics of Advanced Level, Advanced Secondary School Students Book, Form 5 and Form 6. You can order this book. I recommend this book, and I'm going to use the fact I have been a teacher for Basic Applied Mathematics for almost a year. So please refer this book, and you can order it. Its price is reasonable. Then we need questions and answers reference book. We have Basic Applied Mathematics Review, Problems and Solution 2001 to 2016. So it means that you have to do as well as possible. So it means that you can order the package, and even also we have another tool, learning tool, we call it scientific calculator. Make sure you have. The good news, you can order all of this stuff, and then you'll be spending minimum amount of transport cost, right? That is what I would like just to tell you in advance, so that you have to meditate and even you have to take action right now. That's the M-Pesa number. You can send any amount of money from different sectors. Okay? So that's the case that we would like you to discuss. So ladies and gentlemen, again, another thing that, in case you feel from your heart that you want to offer our card, you are feeling Thanksgiving. Don't just stay through this program. Don't just stay, but just tell you are feeling Thanksgiving, so that telephone number, in order for you to know how this program becomes beneficial to you. Okay? So share the contents, like, please, then go to the descriptions, comments, ask your questions, okay, discuss with other students, be active. That's the process. And then we invite in session 4, where we have problem solving about this concept. So, okay, so that is what I've prepared today, and that's what God has told me that to speak it to you. So may God bless you abundantly, and again, I ask you to subscribe. Please subscribe onto our YouTube channel so that you get notification once we add a new video. This is the end of our today's session. I thank God who have given me a gift of teaching. I thank God who have given me you to join me and learn in these contents. And I thank God who have received everything that we have. I thank God who have seen this idea, accomplishments of this idea at the beginning. So I thank God for everything that He has done in my life. Again, I invite you in the next session. Okay? Lord miss you too. And then it's going to be a very interesting session for the lovers of basic engineering, the lovers of advanced basic applied mathematics. So until I meet you in the next session, may God bless you abundantly. Make sure that you watch the video several times as you can. Make sure you do the homework and make sure that you be active and ask your questions in the comment section. That's the this international program, sorry for that, we're focusing about local syllabus. So may God bless you and keep you safely until we meet. Enjoy the beauty of basic applied mathematics.